Today we'll be exploring the damming of rivers, a practice central to human development but with profound environmental trade-offs. Dams have fueled modern civilization. They generate lots of hydropower that lights homes, irrigate vast farmlands, feeding billions of people and protecting cities from floods. Their scale is staggering, considering the Three Gorges Dam, for example, among the world's largest hydroelectric plants on China's Yangtze River, or Egypt's Aswan High Dam, vital for controlling the Nile's floods flow into Egypt, and also Ghana's Kasambo Dam, which transferred a nation's energy's natural landscape into a natural power plant. These structures stand as testaments to human innovation in how dams have benefited society. Their grandeur and utility has been a great improvement to our advancement in society, but we must also ask, what do these benefits cost our environment and the future of our ecosystem, and as well as our children? Dams may be fundamental in society, but they disrupt a river's life cycle by halting the natural sediment transport that normally rivers carry. They upstream and downstream. The sand, gravel, and organic debris downstream, nourishing floodplains, building deltas, and sustaining ecosystems. But when the dam stops this flow, the downstream landscape becomes starved. Exposed riverbeds erode, banks collapse, and once thriving deltas sink. After the Aswan Dam was built in the Nile Delta region, the delta began subsiding and losing soil fertility. Similarly, Ghana's Volta Delta has experienced coastal erosion and shrinking farmlands. On the Yangtze River, the Three Gorges Dam has intercepted roughly about 70 to 80% of the incoming sediment that should be downstream, resulting in the intensified erosion and reduced delta stability, affecting the natural ecosystem and the organisms that live in the water. Tributary lakes like Dongting and Poyang Saw sediment deposition plummet by more than 70%, according to the PMC Science Direct journals. Explaining this in more practical terms, when people upstream build more dams, or land gets deforested, leading to sediment changes downstream as well as upstream. Without sediment riverbanks, erosion happens more heavily during rainy seasons, hurting the buildings and roads and the nearby farmlands. In essence, a dam's immediate benefits can trigger long-term damage to vital ecosystems, constructing and conflicting the infrastructure and the natural habitat that the organisms have, not allowing the organisms to flourish and create the ecosystem needed by the other fish and other animals in the ecosystem. Beyond sediment, dams also act as a physical barrier that severs migration routes for species like salmon, sturgeon, and even some bears migrating to different parts of the river. Features like fish ladders often fail to fully restore because of the altered flow in the water. Altered water flow and temperature regimes also allow invasive species to gain a foothold, while other populations of aquatic insects decline, undermining the food chains and causing an imbalance in the natural ecosystem. For example, the river sockeye salmon were pushed to the brink of extinction because of the Pacific salmon species across the U.S. West Coast continuing to struggle because of the sedimentation block. Consider the Three Gorges Dam. The reservoir disrupted aquatic ecosystems and cut off migratory corridors for the Yangtze sturgeon, the Bahi dolphin, now believed to be in danger of extinction, and other endemic species. A significant drop in biodiversity followed certain fish species adapted to fast-flowing water, declining sharply after being stranded in still reservoir conditions, causing the population to drop. Hydropower is often labeled as green energy, but dam reservoirs can be environmentally problematic, as you've seen when they cut off species from migratory patterns. They also create stratified oligotrophic conditions perfect for harmful algae blooms, especially when nutrient-rich sediments collect near the dam. Moreover, submerged organic vegetation decays and releases about the methane and the CO2 that we see in our ecosystem. 1 to 5% of global methane emissions occur in these dammed areas. Balbina Dam in Brazil, for instance, emits methane gas at rates comparable to fossil fuel plants, rendering the clean hydro label misleading. Meanwhile, downstream water quality can worsen. Algae toxins can compromise fisheries and harm livestock, while decreased oxygen levels degrade aquatic life. Climate models suggest warming reservoir surfaces can even alter the regional precipitation patterns downstream, because of the influx in the temperatures. The dams also can cause a social fallout because of the immense reservoir creations that have taken place, displacing and uprooting hundreds of communities and also submerging cultural land. The Aswan High Dam displaced over 100,000 Nubians, including their ancestral villages, agricultural land. Similarly, Brazil's Belo Monte, Paraguay, Argentina's Yacyretá, and Ghana's Volta projects displaced tens of thousands of people. Many people were relocated without proper consultation or compensation, especially the indigenous groups with deep spiritual ties to their river landscapes. Health impacts plague dam-driven resettlements too. Stagnant reservoirs breed mosquitoes, elevating malaria and bilharzia incidents. Dam reservoirs also enabled invasive species that thrive into the nutrient-rich standing water, leading to declines in wild fish and crop-based livelihoods. Cultural heritage, temples, sacred groves, and fishing traditions all were misconstrued because of the displacement of the populations. In closing, the dams can epitomize a paradox: engineering marvels delivering energy, irrigation, and safety, but also often at a steep ecological and social cost. Yet, as demonstrated by Elwha and Klamath, we can reclaim resilience for rivers and communities when we reconsider outdated structures. The key lies in mindful dam planning, engaging the communities, prioritizing the ecosystems, and reserving the removal or robust mitigation for aging, low-benefit facilities. Policymakers, scientists, and indigenous leaders should collaborate to determine which dams should be kept and which dams should be put in and which ones should be modified. Thank you again, and I'd like to introduce the next speaker in our presentation, Alexandria.